Like all the greatest ideas, this first simple notion, almost whimsical in its origins, was the true breakthrough. But how could he realize it?
Talbot the scientist came to the assistance of Talbot the artist manqué. What he asked himself is the ultimate nature of the picture that is seen in the camera obscura. The answer was to be found in Talbot's favourite subject, light, or more precisely in the action of light and shadow as it fell on the paper in the camera.
Suppose such an action could be exerted on the paper, and suppose the paper could be visibly changed by it. In that case, surely some effect must result having a general resemblance to the cause which produced it, so that the variegated scene of light and shade might leave its image or impression behind.
You could not ask for a more lucid description of the photographic process.
Talbot knew that silver nitrate could turn dark when exposed to light. He therefore reasoned that if an object, such as a fern leaf, were placed upon a piece of ordinary drawing paper that had been washed in a silver nitrate solution, and then was left in the sun, the leaf's impression would be formed in white as the uncovered part of the paper turned black. Talbot eventually found that by coating the paper with a common salt solution first, then with silver nitrate, the paper's sensitivity was greatly enhanced. But this result came only after much experimenting.
On some occasions, certain portions of the paper were observed to blacken in the sunshine much more rapidly than the rest. These more sensitive portions were generally situated near the edges or confines of the part that had been washed over with the brush. After much consideration as to the cause of this appearance, I conjectured that these bordering portions might have absorbed a lesser quantity of salt, and that for some reason or other this had made them more sensitive to the light. This idea was easily put to the test of experiment. A sheet of paper was moistened with a much weaker solution of salt than usual, and when dry it was washed with nitrate of silver. This paper, when exposed to the sunshine, immediately manifested a far greater degree of sensitiveness than I had witnessed before, the whole of its surface turning black uniformly and rapidly.
The key discovery here was that less salt made the paper more sensitive to light. Talbot's genius seized on a further, equally important implication of this. More salt could be used afterwards to reduce the paper's sensitivity and thus fix the captured image.
However, sensitive though it was, the specially treated paper couldn't capture distinctly any image projected through the camera obscura.
Only by experimenting with alternate washes of salt and silver and exposing the paper in a moist condition in the camera did Talbot begin to obtain more satisfactory results.
The way was now open for literally taking pictures.
In August 1835, Talbot took the earliest known surviving negative of the oriel window in the South Gallery at Laycock. It is 1 inch square, and as a result of the salt fixing process, a delicate lilac in tone. He had also begun to realize another major discovery: how to make positives.
If the paper is transparent, the first drawing may serve as an object to produce a second drawing, in which the lights and shadows would be reversed.
With this typically lucid statement by Talbot, modern photography was born. And yet a few years later, in 1840, the master magician pulled off yet another remarkable coup de théâtre. By experimenting with different chemicals, principally gallic acid, Talbot found he could take a short exposure, remove the paper from the camera, and then develop the latent image. The short exposures, sometimes only seconds in strong sunlight, meant that for the first time people could be photographed. Talbot's wonder at his invention was evident.
I know of few things in the range of science more surprising than the gradual appearance of the picture on the blank sheet.
The picture on the blank sheet